photoelectric effect. Photoelectric effect, or it can also be called a photoelectric equation. Let me consider a metal plate. When a light falls on it, electrons are ejected. These electrons are called photoelectrons, and this is the light. So the phenomenon of ejection of electrons on irradiation on the metal plate is called photoelectric effect. We know E is equal to h nu, where h is Planck's constant, nu frequency, E energy. We know the value of a Planck's constant, that is equal to 6.625 or 6 into 10 power minus 34 joule second. In fact, this h nu is represented as photon. It is called one quantum of radiation. That is called photon. What do you mean by photon? Which is nothing but one quantum. One quantum of radiation of light. Is called photon. And that too travels with the speed of light. Speed of light is 3 into 10 power 8 meter per second. Now let us discuss about the properties of these photons. Properties of photons. All photons emitted by any source of light that travel through free space with the speed of light, that is c is equal to 3 into 10 power 8 meter per second. And each photon has a definite energy that is given by h nu. We know C is equal to nu lambda, therefore nu is equal to C by lambda, and this 1 by lambda can also be represented as nu bar, that is called wave number. Lambda, you know, wavelength. C is the velocity of light. So this equation can be represented as, that is, the nu can be replaced by C by lambda, so C by lambda. And this is also represented as hc into 1 by lambda. We know 1 by lambda is nu bar, so you can put hc nu bar also. So all of them are energy. In fact, the frequency of the photon does not change when it travels from one medium to another medium. Frequency, that is represented by nu of photon, does not change. does not change. When it travels from one medium to another medium. The speed of photon changes as it travels through different media. So the speed of photon may change when it travels through different media due to the change in its wavelength. So speed changes with respect to different media. Why? Because lambda changes, but there is no change in the frequency. So it is because of the change in the lambda and the speed, there is a change in the energy also for each photon. In fact, these photons are electrically neutral. Therefore, not deflected by electric field and magnetic field. However, they may collide with each other. They collide. With a material particle. So the total energy and the total momentum remains conserved as per the conservation of collision. So energy is conserved, the momentum is also conserved. Energy and the momentum conserved. P represents P is equal to mv, mass into velocity, that is momentum, linear momentum in this case. So in this case, the number of photons may not be conserved, it may change. So here you should note down one more important point. This may be conserved, but the number of photons may vary. Not conserved. Suppose when you increase the intensity of light, I represents here intensity of the incident light. So when you increase the wavelength, the intensity increases if the intensity of the light of given wavelength is increased. So in this case, we are increasing the intensity alone of a particular wavelength. There is an increase in the number of photons. There is an increase in the number of photons. Photons incident. Excuse me. On a given area in a given time. But energy remains same for each photon. Next point. As the particle varies according to the relation m, the mass, is equal to the rest mass m0 divided by the whole square root of 1 minus v squared by c squared. In fact, this m naught is called rest mass of the particle. C is the speed of light. V is the speed as a mass, speed of particle. When the speed of light, speed of particle is on par, that is equal with the speed of light, then it means it loses its mass. Why? Because V is equal to C means it becomes 1, 1 minus 1, 0. So m0 divided by 0, m naught divided by 0 means it is infinity. It means it doesn't have mass. It loses its mass. So it means the rest mass is 0. When V becomes C, what do you understand from this? When the velocity of the particle is equal to the velocity of the light, what happens here? This becomes a 0. So you can bring this here, so it becomes m naught becomes 0. The rest mass becomes 0. That is, rest mass of photon is 0. In fact, the moving mass m of a photon is determined by Einstein's equation. Einstein's mass, the famous E is equal to mc squared, is it not? Mass energy relationship. Therefore, E is equal to mc squared. We already know E is equal to h nu. And we can substitute this E as hc by lambda also. So on comparing these two equations, we can get, that is, mc is equal to, that is, h nu by c. And that can further be equate, because I have brought the c here. So nu h nu by c. LHS are equal, RHS must be equal. So mc squared is equal to hc by lambda. So I have put, that is, mc and c I have brought here. Because we already know c is equal to nu lambda, you can note down this. It means c by lambda or nu is equal to lambda. So I have substituted lambda, so made it as hc nu divided by c. So this becomes h by, that is lambda, nu by c means 1 by lambda. So this is h by lambda. You can substitute this, is it not? You can reciprocate this. So nu by c is equal to 1 by lambda. So I have put h by lambda. So mc is equal to h by lambda. And when c becomes v, we can consider momentum, mv, that is momentum. That is represented as p. So you can make use of this equation as P. Therefore, P is equal to h by lambda. That is, momentum is equal to h by mv is equal to h by lambda. So v replaces the c, indicating that this behaves as a particle. In this case, when there is no mass, means it behaves as a wave. So he was able to relate these two, energy and mass. When we discuss about the photoelectric equation according to Einstein, we should consider another important parameter called work function. What is work function? It is the minimum amount of energy required by electron for what? To escape from the metal. From metal surface. So this is called work function. So what is work function? It is a minimum amount of energy required by an electron in order to escape from the metal surface. For example, let me have the metal surface like this, and you are attacking with a light. So a light is incident on the metal surface. So you cannot expect, that is, the entire energy is used up and all the electrons will be kicked out. Not like that. So some amount of energy is required to accelerate this electron. Okay. So, and that is called work function. Clear? So that some electrons will be moving from the surface of the metal. So this work function is represented as W naught, and it is given by the unit SI unit electron volt. So one electron, it's a kinetic energy of electron, is it not? This is the kinetic energy of the kicked out electron, emitted electron. Because some moment we can say kinetic energy of electron gained by an electron instead of for emission. So this is gained of electron, kinetic energy of energy gained by electron. By the electron. So some amount of energy is used up. So in order to, that is, kick out. So that is W naught. That is the work function. Okay. So photoelectric effect is the phenomenon of emission of electron from surface of a metal when radiations of suitable frequency fall on it. That is very important. So when we discuss about this energy is equal to the work function, that is the energy consumed by the electron or gained by the electron, that is called work function. plus this is liberated as a kinetic energy of electron, is it not? So maximum amount of kinetic energy. So you can put kinetic energy maximum. This is the total energy. So the total energy, this is E h nu. So you can replace by total energy of incident light h nu is equal to, and the W naught can be replaced by h nu naught, because that amount of frequency is used up, that energy is used up by the electron in order to get ready to be kicked out from the metal. So h nu naught, and what is this nu naught? That is called threshold frequency. That is the maximum, it is the minimum amount of frequency, okay, with which it can be kicked out. Okay, so threshold frequency, this is called threshold frequency. And so we have got here h nu, that is equal to h nu naught, plus what is the kinetic energy? Half m mass of electron, and then v, the maximum velocity with which it can travel as kinetic energy. Now we can calculate this kinetic energy, that is a half mv squared. We can take this one, so it can be brought here. Therefore h nu minus h nu naught is equal to 1 by 2 m v max squared, right? It means h being constant, I mean we can take outside the bracket, so nu minus nu naught is equal to half mv squared, mv max squared. So definitely this kinetic energy should be positive, okay? Kinetic energy cannot be negative, it should be positive. If it is positive, and nu minus nu zero must be positive, is it not? So therefore nu minus nu naught must be positive. It means what? That is nu is greater than nu naught. Are you able to follow this? Therefore, the incident radiation increases, the kinetic energy carried by electrons will also increase. Let us consider the intensity parameter. The intensity increases. This increase of intensity increases the number of photons, is it not? So when the number of photons increases, kinetic energy also increases, is it not? Therefore, more stopping potential is required. Are you able to understand this? More stopping potential is required. more stopping potential is required to stop the photoelectric current. Photoelectric current. Now let us determine the Planck's constant. Determination of Planck's constant. Determination of Planck's constant. The kinetic energy maximum is equal to h nu minus h nu 0 according to the equation we already derived. Now let me consider a graph plotted between the nu in x-axis and Ke max in the y-axis. So as we know, this is the minimum frequency required to exhibit the photoelectric effect. So photoelectric effect can occur only after crossing this, is it not? So where you can note down, so this can be the kinetic energy, okay, kinetic energy maximum. So it reaches certain amount of nu, and below which it will not exhibit any electron, and it reaches certain lowest value A. Now at A, right, at A, what is nu? Nu is equal to 0 because it is in x-axis, is it not? So nu is equal to 0. It means no frequency. Therefore Ke max is equal to h nu becomes 0 minus h nu 0. It means it is negative, is it not? So minus h nu naught. It means we can call it, this is O, so it is OA, minus OA, right? So this work function, is equal to the negative of the intercept, on y-axis. That is at A, right? Now, based on this equation, so we can rewrite this, that is h of nu minus nu naught is equal to Ke max, is it not? From this we can find out the value of h, that is Ke max divided by nu minus nu naught. Okay. So what do you mean by this? Ke max means dy, am I right? Correct? And the nu minus nu naught means, which is nothing but, that is the dx. Are you able to follow? So this is the slope. So when you are able to find out the slope, that is nothing but k, h. So here we can represent the h as the slope of this graph. Are you able to follow? Therefore, what is h here, which is nothing but slope dy by dx of the line obtained in this graph, that is constant. Now if V naught is the stopping potential, so we know this stopping potential is required to exhibit this kind of that is almost equal to the kinetic energy of the kicked out electron, is it not? So kinetic energy of the kicked out electron is equal to what? This EV naught. Okay. Therefore, V naught is equal to kinetic energy maximum divided by E. We already know KE max is equal to what? H nu minus H nu naught. So we can replace this with this equation. Therefore, EV naught is equal to H nu minus H nu naught, right? It means V naught is equal to HV divided by E minus H nu naught, H nu divided by E, H nu naught divided by E. Am I right? Now the slope becomes, that is, H by E. It means H is equal to slope into charge of electron. When I say slope, it is the slope of the slope of the curve obtained from potential, that is what potential? V naught means what? Stopping potential versus new curve. Nu is the frequency. So we can draw another graph like this. So here this is the stopping potential and this is the nu naught. So above which what occurs? Kinetic energy occurs. So that is equivalent to the stopping potential. So here it is nu, and you can extend here. So you can find both graphs are almost same. So the same slope can be interpreted as H by E also. Therefore, now this intercept is equal to, we have got the work function. What is this work function? Which is nothing but nu naught, that is a WO. So work function divided by E, because W is equal to here H nu naught, is it not? So work function, it can be replaced by work function. So work function, and this leads to a negative one. So intercept is equal to minus of work function divided by E. So this is another important relation. Okay. So we have interpreted this graph in terms of kinetic energy of the kicked out electron as well as the stopping potential required to stop the photoelectric effect, right?